All right, we're back with example 3. We're going to be proving lines are parallel. So we're starting to deal with pictures that are just a little bit more complicated, but we're going to apply all the things that we have learned, so we can totally do this. So we're given that P is parallel to R. Okay, so let's just take a moment and just think about that. Why would they tell us that these two lines are parallel? Okay, so whenever they tell you that two lines are parallel, what should automatically pop into your mind are, number 1, the corresponding angles postulate, number 2, the alternate interior angles theorem, alternate exterior angles theorem, and same side interior angles theorem. So whenever you see something that, you should automatically know, hey, I could apply one of those things to show that two angles are congruent to each other, okay? So this is really, really super important that, like a light bulb, red flashing light, something goes off and you immediately think about, oh, those 4 postulates and theorems that you learned in the previous section or lesson. Okay. The other thing that they give us is that angle 1 and angle 3 are congruent to each other. What our task is to prove that line L and line M are parallel to each other. Okay. So let's just think about this for a little bit. Before we start doing a formal proof, I always just like to think about it and see if we can kind of come up with something here. So number 1, we know that these two lines are parallel. Okay? We have these two lines right here. Okay, what I see is these two parallel lines being cut by this transversal. So I can just take away that part and it just becomes a lot simpler, right? And then I see that these two parallel lines are also being cut by this transversal right here, L. The one thing I notice about this one with angle 1, there really is no other angle that's named here. So I can't really show that two angles are congruent to each other because there is no other angle. However, when I look at over here, I have these two lines are parallel, and then it's cut by this transversal, and then I have two angles. Now, my question is, what are these two angles? Do they have a relationship with each other? And if you see angle 2 and angle 3, they are alternate exterior angles. So what that means is because these lines are parallel, we know by the alternate exterior angles theorem that these two angles are congruent to each other. So that is huge. We can say that because these lines are parallel, we know that those two angles are congruent to each other by the alternate exterior angles theorem. So we know that these two angles are congruent, and I'm just going to show that they're just the same color, just showing that they're congruent to each other, okay? Perfect. So we know that. What else do we know? We know that angle 1 is congruent to angle 3. So because of the given information, we also know that these are congruent. So at the end of the day, all of these angles that are green are all congruent to each other. Now, how does that help us with L and M? Because that's what we're trying to prove, right? So there's no parallel marks here. We have to prove that they're parallel. But if you look at these two, right, we know that these are congruent, right? So because these are congruent and these are congruent, so we can say that those are congruent by, do you remember what that is? If these two are congruent and those two are congruent, why we can state that those two are congruent? That is the transitive property of congruence. So once we're able to state that those two are congruent, really, what do we have here with L and M? I'm going to kind of take this away. L and M, this is the transversal. Those look like they're corresponding angles. And if those corresponding angles are congruent, therefore, by the converse of the corresponding angles theorem, we can prove that L and M are parallel. So that's really how we're going to solve this whole thing. So let's go ahead and start. So right here, they give us this information. P is parallel to R. So that is given. And I always like to say, okay, so they're giving us then what? Well, what we can use, what we can play off of that is that because these lines are parallel, we know that angle 2 and angle 3 are congruent to each other by the alternate exterior angles theorem. Okay? So then, right, we prove that those two are congruent. Then we can go to this other piece of given information and say that, hey, angle 1 is congruent to angle 3 because of it's given, right? And then if you can see, angle 3 and angle 3 are the same. So since angle 2 and angle 1 are congruent to the same angle, therefore we can say that they are congruent to each other by the transitive property of congruence. Okay, so now we have 1 and 2, and that's really all we need to prove that L is parallel to M by the converse of the corresponding angles postulate. So boom, there you have it. That's it for example 3. Let's go ahead and look at, check it out, example 3, okay? So we have another kind of a lot more of a confusing picture here. So we have angle 1, angle 2, angle 3, angle 4, L, M, and N. Okay, all these lines, and we have this wonderful transversal. So let's see what they give us here. So at the first, they say angle 1 is congruent to angle 4. I'm going to go ahead. There needs to be, it was just a misprint. So go ahead and write that angle in there. Okay. And angle 3 and angle 4 are supplementary. Okay, so we have angle 1 being congruent to angle 4, and then they have angle 3 is and 4 are supplementary. And we need to prove that L is parallel to M. Okay, so what I want to do first is I'm just going to take this away and look at LM and just see what, so right, to prove that these are congruent, I'm either going to have to use the converse of the corresponding angles postulate, the converse of the alternate interior angles postulate theorem, the converse of the alternate exterior angles theorem, or the converse of the same side interior angles theorem. So I'm going to look at these like just the angles that I have, and I want to see like what do you think I'm going to be using to prove that these are L and M are parallel. So I see this 3, right? So if I was using the corresponding angles postulate or the converse, I would need to know this angle right here, and there is no like number there, so it's probably not going to be the converse of the corresponding angles postulate. It's not an interior angle, so it wouldn't be the alternate interior angles theorem or the same side interior, but it is an exterior angle, but I don't have this one, so we're probably not going to use the converse of the alternate exterior angles theorem, which really means I can't really use this angle. None of the 4 theorems work as far as using this angle to prove that those two are parallel. So what that tells me is since there's no option for 3 really, that means I'm going to be using 1 and 2 to prove L and M. And what are 1 and 2? Well, they're both interior angles, and they're on that same side of the transversal. So basically, this looks like I would most likely, the only way that I can prove that these two lines are parallel is by the converse of the same side interior angles theorem, which means I have to show that angle 1 and angle 2 are supplementary. Okay? Are you guys with me on that? So there's a lot of stuff going on, but I kind of want to just go to the end of the proof and figure out, hey, what am I going to be doing here to show that these two are parallel? Because really, I only have 4 options, right? So this tells me that I'm going to be using the converse of the same side interior angles theorem, and I have to show that these two are supplementary, okay? So with that said, let's look at all of the stuff. So it's basically saying that 1 and 4 are congruent, okay? So that is the first piece of that. So I'm just gonna, use this. So we know that these are congruent. Okay, that's awesome. And then what it says is, it says that 3 and 4 are supplementary. Okay, that means they add up to 180 degrees, right? So I'm not going to use the same color green because I'm using green to show that they're congruent, but I'm going to show that these are supplementary by just using this yellow. Okay, so these two angles are supplementary. All right. And I really need to show that these two are supplementary, but the yellow and the green, that kind of shows that it equals 180 degrees. So, but I need to show that these two are supplementary. Is there anything you guys see? Hey, what about this? Vertical angles. So by the vertical angles, we know that angle 2 and angle 3 are congruent. And then there we have it. We have that those two are supplementary as well. And since they're supplementary, we could do the converse of the same side interior angles and prove that the L and M are parallel. So that's kind of like a game plan, but let's go ahead and, so we have an idea what we're going to be working with. But let's go ahead and start the proof. Okay. Okay, let's start with this first bit right here. Angle 1 and angle 4 are congruent. Okay, and that's given. And really, when we're talking about supplementary, we have to prove that these are supplementary. So we know that we're going to, at some point, have some type of equation that's going to be measure of angle 1 plus measure of angle 2 equals 180 degrees, right? So because of that, we're going to be using an equal sign. So I'm going to go ahead and just change the format of that so that at the right time, I can use this information into the equation. So that is just, so I'm changing the format. So definition of congruent angles. Perfect. And really that's all I can go, that's as far as I can go with this. Angle 1 is congruent to angle 4 at this time. So let's go ahead and jump to the angle 3 and angle 4 are supplementary. Okay, just supplementary, and that's given. And then because of that information, I can go ahead and write an equation. Measure of angle 3 plus measure of angle 4 equals 180. Do you guys know the reason for this? Do you remember? By the definition of supplementary angles. All right, if you said that, you were right. Okay. So at this time, I can start to substitute. I can substitute this. So our goal is to say that measure of angle 1 is plus measure of angle 2 is equal to 180. Right now we have measure of angle 3 and measure of angle 4. But I can substitute, measure of angle 4 is the same thing as measure of angle 1, so I can substitute that measure of angle 1 in there. And I get measure of angle 1 equals 180 by substitution. Okay. So I'm getting closer, but I need that measure of angle 2. How can I do that? Well, I can show that these are congruent, right, by the vertical angles theorem. So I'm going to say measure of angle 3 equals measure of angle 2 by the vertical angles theorem. Then just go ahead and substitute that in, right? Measure of angle 2 instead of measure of angle 3 plus the measure of angle 1 equals 180. That's substitution. And then we have exactly what we need, right? We need to show that these two are supplementary in order to prove that L is parallel to M, which is what we did by the converse of the same side interior angles theorem. All right, so that's it for example 3. We'll see you in a little bit for example 4.